Okay, let's start. So today I'd like to try a new way to present a lecture, because normally I would use just my pad and um, write notes as I tell them. Today I have discovered I'd like to start typing them, so you have a not so complete, but more or less editable notes of lectures, and that will be a little experimental. So I don't know how to deal well with pictures yet, but let's try. I think that having editable version of lecture notes is a good idea. So let's go on. Let's share, and I will. So if you have any questions, just don't be shy. Just say, "Oh, what is bum, bum, bum?" Or just don't waste time to ask, can I ask a question? Yes, and the question. Just ask the question, and don't be shy, because we have a lot of materials available online. So we need to make lectures and classes as interactive as possible. So your questions are the best thing we can have to make lectures more interactive. So let's start. I will share my screen. Oop. And then I will have a preview. Oop. Like this, I think. Okay, here is a short plan for today. Lecture 1 and 2. In lecture 1 and 2, we will discuss ETS models. So ETS stands for error, trend, and seasonality models. So here I have provided 2 links. So if you'd like to read more, the first one is just lecture slides by Hindman, and the other one is the book Forecasting Principles and Practice. So if you'd like to have more, I think these 2 are the best sources on ETS model, because Hindman was one of the men who has made a revolution in ETS models. So first, let's start with some general conceptions in time series. So first definition, what is a stochastic or random process? How do you think? What is a stochastic or random process? What's your opinion? Don't be shy, just your version. What is a stochastic process? Can you hear me? Ooh. What's your idea? What can be a stochastic or random process? Kind of stochastic analysis. No stochastic analysis, which is not dependent on other process. No, just the sequence, of random variables, nothing more. Just the sequence of random variables. I will make a font a little bit bigger, or maybe no. So I'm not sure how it's better for you. So if you'd like to have bigger font, just say me. So it's just a sequence of random variables. So if you have a sequence y1, y2, normally the time index may start in -infinity, or we may start from 0, or we may start from 1. It doesn't matter. So we have y4 something. So just a sequence of random variables, nothing more. They may be dependent. So let's start with first the very basic, I think, or even like this. The simplest random process is called white noise process. Definition: white noise process. What is a white noise process? Have you heard about white noise process? Which is not dependent. It was answer for the previous question. You're a little bit right. We say that. So just a small remark. Normally, when we have one random variable, we denote it without brackets. Y1 is one random variable. But if we have a sequence of random variables, it's a tradition to denote it in brackets. So in brackets, YT means a sequence Y1, Y2, Y3, and so on. So white noise process, let's call it UT in brackets because I have a big number, U1, U2, U3, U4, U5, and so on. And the requirement are some answers are very good. So what are the requirements to be a white noise process? We have the following requirements. Expected value of UT should be 0. So it should be uncorrelated, it should be 0 on average. Variance of UT. I don't know how have you denoted variance in econometrics, but I think it was either var or d, but I will denote like variance in English. So the variance should be constant. So that means 0 expected value. That means constant variance. And as one of the comments mentioned it, I think it was Nikolai. Yeah, you are. Nikita, sorry. Nikita is right. Nikita said that covariance of UT and US should be 0, or correlation. That doesn't matter. Covariance is proportional to correlation. For T not equal to S. So different random variables are uncorrelated. So that is the definition of white noise process. It may or not be normal. Yes, Konstantin is more or less right. Sometimes we will use normal distribution, but in the definition of white noise process, the normality is not required. Okay, let's move on. We have described just a sequence of random variable white noise process and a more complex notion of stationarity. Stepan mentioned the notion of stationarity. So there are two kinds of stationarity. First, let's discuss weak stationarity. The process YT is weakly stationary. Mainly, we will need weak stationarity. Is weakly stationary if what? Stepan, you have mentioned stationarity, so maybe you know what is it? What are the requirements for stationarity? Who knows the requirement for stationarity of a process? Constant mean. Yeah, we need. We will just copy constant variance. We will copy constant expected value. So we will just change it like constant expected value. And we should have here, oops, it was y, and that is also y. So constant expected value. And we need some more about covariances. Covariance of yt and ys should depend on what? Should be function. Konstantin, Stepan, do you know what is the requirement for the variance, for the covariance in stationary process? Who knows? Maybe anyone? Okay, it should be the function of the difference of t minus s only. So let me explain a little bit. So covariance depends only on difference of t and s. Basically, for example, that means that covariance of y1 and y2 should be equal to covariance of y3 and let's say y4. So two adjacent indicators today and tomorrow may be linked. That's not prohibited in stationary process. They may be linked, but covariance of y1 and y2, there is exactly 1 day between them if we speak about daily data. So it should be equal to covariance of y3 and y4. Okay, just a small question to you. Just a small brief question. I will provide you two covariances, covariance of y1 and y10, covariance of y2, y10 and let's say y19, and covariance of y3 and y10. Which two covariances should be equal in a stationary process, in a weakly stationary process? Yeah, Konstantin is right and Misha is right, because between y1 and y10 we have 9 days if we speak about daily data. Between y10 and y19 we have 9 days, and between y3 and y10 we have only 7 days. So covariances, all three covariances may be non-zero. That is not required in a definition of a weakly stationary process, but you are right. These two are equal. Okay, and short answer that these two should be equal for a stationary process. Okay, let's continue. So now we have a definition of weakly stationary process. We have a definition of random noise. We may state our first theorem. Yeah, theorem. White noise is a stationary process. Why it's so? But let's look at the definition. In weakly stationary process, we need constant expected value. In white noise process, we have zero expected value. That's okay. Variance should be constant for stationary process, and variance is constant. Covariance should depend only the time difference between two observations, and it's zero, so it's okay. It does not depend even on T and S. Not on T, or not on S, not on T minus S. That's okay. So let's provide some small exercises. Another good name, proof. Let's just check the definition. Okay, let's provide another process, which is more or less famous. Definition, what is a random walk? Who knows what is a random walk? I don't hear you. Who knows what is a random walk? Something is correct. Yeah, a little bit, not exactly, but something. There is some rational seed. It should grow, but a little rational seed I can see in your remark, Konstantin. Yeah, let me discuss. A random walk is something that moves randomly. So what is the idea behind random walk? Let me just share the screen, because sometimes I will draw and I will include pictures later. So I will just share the screen. I cannot, why I cannot share if the other participant is sharing? What is the idea? Why I cannot share more? Just a moment to how can I at least I can draw here. Yeah, I can draw something that will disappear. Okay, the setup of this account for the moment doesn't allow simultaneous share, but I will go through it. Okay, yeah, we have a random process of random steps. That's a good noise. That's a good idea. So basically, we have so once again, YT is a random walk. If we have some constant initial value of the process, Y0 is some constant. I don't care which one. And then YT is equal to YT minus 1 plus a random step. And random step is a white noise process. Yeah. YT is equal to YT minus 1, previous value, plus UT, where UT is a white noise process. So basically, in white noise process, every state is not correlated with the past, and in random walk, yeah, we can have something like this. In a random walk, we can have YT is correlated with YT minus 1. We have explicit formula even. YT equals to YT minus 1 plus some noise, some error, and this error is a white noise process. Okay, let's solve some small exercises. And let's let me make definitions in bold. that will allow white noise process. Okay. Okay, let's move on. Let's solve some quick exercise. My small question is let yt be a random walk, and we have just system of equations like let's write a system of equations. Y0 is let's say 0, and yt equals to yt minus 1 plus ut. Ut is a white noise process, and my question is with, let's say, with variance sigma squared u, and my question finally is find expected value of yt and find variance of yt is yt stationary. So here is my question. I hope you can see it. What are your ideas about expected value of yt? Who can find it? Why, Konstantin, expected value of yt is 0, and why? Why expected value of yt is 0?
Because it is a kind of iteration. We can use a formula for yt using y0. So
yeah, we can start step by step.
Yes.
Yeah,
so
you're right. So let's write what is the value if y0 is 0. What is the value of y1? Y1, let me find y1. So it would be answer. So let's proceed step by step. Y1 is equal to
y1 is equal to 0 plus ut and
plus u1.
Yes, plus u1 and
simply u1.
Yes.
Okay. What is the value of y2? Y2 should be equal to y1 plus u2. Any questions? Am I going too fast? Am I going too slow? Everything is more or less okay. Let's check. You are too shy to say something aloud. I don't understand why. So my question is just if you are with me, just raise your hand. You have an option to raise your hand. So if you understand everything, so just raise your hand. If you are already lost, then just do not raise hand. I need to understand what is the proportion who is with me, because they are too shy to say stop or to say aloud that everything is fine. Oof, less than 1/2. Okay, so if everything is fine up to now, then just raise a hand that you are with me. Okay. Less than 1/2. 1/2. Yeah. 1/2. If you have any questions, just don't be shy. Just We will solve the problem step by step. That's not a problem. Okay, I will continue, but once again, Alena, Alexey, Igor, German, Ilya, Ivan, Mikhail, Sergey, Polina, Stepan. If you have any questions, if I'm going too fast, if something is, if you have some, I don't know, some more time to think, then just ask me. We have a short course. We have 6 lectures. Yes, we cannot waste time, but it's better to say something once again than to lose 1/3 of students. Okay, so I'm calculating basically y1, y2 step by step. So y2 is equal to y1 plus u2. And y1 we have already calculated. It's u1. So we have u1 plus u2. Let's calculate y3. y3 is equal to y2 plus u3. What is the value of y2? We have already calculated it. It's u1 plus u2. And plus, we add what? Yeah, Nikita is right. We add u3. I think it's more or less sufficient to guess that in general, in this model, in a random walk model, yt is equal to u1 plus u2 plus l dots plus ut. Or if you prefer some kind of writing equations with sums, then you can say sum from I equal to 1 up to t ui, yeah? Something like that. Okay, and now let's we have explicitly expressed y1, y2, y3 using u1, u2, u3, and so on. And now we can easily answer the question whether the process is stationary. So now it's more or less easy to see that expected value of yt is expected value of u1 plus expected value of u2 plus dots plus expected value of ut. And this is 0 because we have agreed, we have assumed that that ut is a white noise process. Okay. So expected value of our random walk is 0 plus 0 plus 0 is 0. Let's move on to the variance. What is the variance of, let's say, y1 is a variance of u1, and it's equal to sigma squared. What is about variance of y2? It's variance of u1 plus u2. And we know that these two random variables are uncorrelated. It's an assumption of white noise process. And then I simply add variances because variance of a sum is sum of variances for non-correlated random variables. And it's equal to 2 sigma squared u. And probably you can guess that if I have, if I speak about yt, Then I have u1 plus u2 plus u3 plus plus ut. Then I will calculate the variance of this random variable. If I will calculate the variance of this random variable, oops, I will have a lot of, if I will calculate the variance of yt, I will have the variance of all these u1, u2, u3. I will have a variance of u1 plus variance of u2 plus, I will have a lot of variances here, plus variance of ut, and finally I will have t times sigma squared u. And now a small question for you. Is the process of random walk stationary, weakly stationary? No, because variance is not constant. Yeah, variance is not constant. So yt random walk is not stationary because variance goes up. Okay, so that's some basic terms in basic notions in stochastic processes. So let's recap what we have done up to now. We have so the first question is how to avoid current lecture, how to skip current lecture. Yeah, the first question we have answered is how to skip current lecture. So you just read this chapter on ETS models in a book, and these slides, if you like to just skip them, that's okay. Okay, then the definition of stochastic process, just a sequence of random variable. White noise process, very simple process with zero correlations, with zero expected value, with constant variance. What is a weakly stationary process? A process with constant expected value, constant variance, and covariances that depend only on time difference. Okay, then we gave a definition of random walk, that it accumulates white noises and it is non-stationary process. Okay, let's move on to our model that is really used for forecasting. It's simple model, but it's widely used to forecast monthly data. And even if you have a more complex model, not just ETS AAA, but a more complex model. However, you can use ETS AAA to make better prediction. You can just average predictions from two model, or use forecasts from ETS in your, I don't know, random forest or gradient boosting algorithm. You can use the prediction of this model, and this model is very simple. And for this simplicity, it's some quality of forecasts. So it's very simple model. Okay. If you have no questions about general terms like random walk, white noise, weakly stationary process, then let's move on to the ETS model. And if you have questions, just don't be shy and ask them. Okay. First, let's consider ETS model without noise. Yes, it contains noise, but to expose the model, I'd like to just start. Imagine that we are in a deterministic world without noise. Just imagine, and we will, because how to understand the equations better, it's better to just make them, like we will make ETS model by ourselves. So Imagine a very simple world, no noise, no randomness, just deterministic process for monthly time series, or maybe quarterly. It will be shorter to write. We have imagine that our YT is some quarterly time series. So we have 4 values each year: Y1, Y2, Y3, Y4. Y5 is next year, Y6 is next year, and so on. Okay, and imagine a model with no error for the moment, but with trend plus seasonal effects. And let's introduce some notation. Okay, YT will be our observed time series, quarterly. We will introduce that is time series cleared from seasonal effects. So that is time series cleared from seasonal effects. We will introduce some more notations. BT will be current growth rate. And what I need, ST will be current seasonal effect. It may be positive, may be negative. Okay, so notation is clear. We have YT, we have LT, we have BT, and ST. We have 4 processes. Yeah, YT, we have Y1, Y2, Y3, Y4, and so on. We have L1, L2, L3, L4, and so on. And we have BT, B1, B2, B3, S1, S2, S3, and so on. Notation is clear. We have observed time series. We have time series unobserved. It's something imagined, created by a man. Time series cleared from seasonal effects. Then we have current growth rate, and we have seasonal effect. That is also, these are also artificial time series. We do not observe in a real life something with clear seasonal effect. It's our opinion about time series. Okay, notation is clear. Okay, Dmitry, Konstantin, thank you. Okay, so let me draw a picture. I will try to add it into the into notes. I think so. Let me. I don't know why this setup doesn't allow sharing, simultaneous share. Okay, I will. For the moment, I will stop sharing and I will quickly check the setup because I would like to have a simultaneous to show you a picture simultaneously, but it's not allowed. Okay, just 30 seconds. I think I will master the setup. Okay, share screen. Multiple participants can share. Now I will share lecture. Opa. And now I can share. Why I can't share? It was allowed. Multiple. Share screen. Multiple participants can share. What's wrong? Okay. Bum, bum. Okay, the picture is very simple. So we have T. I will draw a continuous line, but we work with in discrete time settings. I'm just lazy, so I will draw a continuous line, but remember, we have discrete time, Y1, Y2, Y3. We have no Y 1.5 or Y 0.7, no such terms. So our series, I recall that for the moment, we are in a deterministic world, no randomness. So we have something like this. It fluctuates completely predictable in a completely predictable way. So this is YT. We have something. This is LT. This is LT. The black is, so this is LT. The black one is YT. So it's a very simple model. So let's describe it in equations. BT is a growth. So no, I will move back, and I think I will include the picture in notes a little bit later. Okay, I think the picture is clear. Everything is fine with the picture. It's very simple. We are in a deterministic world. Yeah. Okay. But why? I don't understand. I have multiple participants can share simultaneously, and I cannot share simultaneously. That's something wrong. Okay, let's move on. Let's move on to equations. So BT is current growth rate of LT. I will be a little bit more exact. It's current growth rate of cleared time series. Okay, let's write equations. Let's write equations. We have a system, a big system of many equations. And the first equation is very simple because we have no noise. The growth rate is constant. Okay, the first equation is very simple. Yeah, we have no randomness in our deterministic world, so growth rate is always 2 or 5. It's very easy. Okay, now let's move to seasonal effects. If we live in a deterministic world, that doesn't mean that January or December is like July. Yeah, we have just non-random fluctuations. So in winter, in winter, let's say, imagine because of New Year, people buy a lot of presents, so expenditures are bigger than in summer, but the effect is constant. The difference between summer and winter is constant in our model. So equation for ST, who can guess the equation for ST? What should I write here if I have 4 seasons and I assume that fluctuations are not random? What should I write there? What is the value of current seasonal effect? It should be equal to S. Yeah, to the effect, to the seasonal effect of past year. Yeah, to the ST minus what? No. We have 4 seasons each year. Yeah, to the ST minus 4, because S1, S2, S3, S4. S1, let's say this is a seasonal effect of winter, of this year winter. S2 is a seasonal effect of this year spring. S3 is a seasonal effect of this year autumn, and so on. And S5 is a seasonal effect of next year winter, and S9 is a seasonal effect of a winter 2 years late, and so on. So the equation for ST is also very simple. Let's move on to LT. LT is, how do we write equations? We express current value using past values. It's a dynamic system, so current values depend on the past values. We will add noise in 5 or 10 minutes, so we will add noise, but to start simple to understand the logic of the model, let's write equation. It's a dynamic system, so current values depend on past values. So in the right hand side we have current values, in the left hand side we have current values, in the right hand side we have past values. Okay, basically because LT is a cleared from seasonal effects version of YT, so in our deterministic world it evolves in a very simple matter. We take previous cleared value and we add growth rate. So we add growth rate, we add BT minus 1. So this is growth rate of this is analyzed version of Y. And now the final equation, the equation for Y. Who can tell me the equation for Y? YT is not cleared from seasonal effects. So basically, I should add to current LT, I should add the corresponding seasonal effect. And basically, I take LT, I add plus ST minus 4. Okay? The model is clear. It's a very simple model. Any questions about equations? Why ST minus 4? Because we are building a dynamic model. In dynamic model, we express current value using past values. So we cannot use it. We cannot use current values in the right-hand side. So this part should contain only past values. Right-hand side should contain only Konstantin, once again, left-hand side of equations contain current value, current value, BT, ST, LT, YT. On the right-hand side, you cannot use current values. You use past values. Current values in our deterministic model are completely determined by past. We will add random noise into right-hand side, but later. For the moment, in a deterministic system, current values are determined by the past. If you consider some physical experiment, I don't know, you take what again? You have a razor, that is the current location of razor, and the future location of a razor depends on the past location. So the idea, we have Nikita asked, then how they could be equal? They, who they? They, who they? BT, and what's the problem? BT, it's this, sorry, I don't understand exactly your question. Why can be equal? Because I have written that they're equal. I have assumed BT is just BT minus 1. Maybe to better understand, let's just provide some initial values, and from starting values we can calculate all the future. So we also need some initial values. Maybe just wait, we will provide some initial, we need also initial values. So let's provide some initial values. Let's say that B0 is 2. Let's say that L0 is let's say L0 is let's say 100. Let's say that S0 is 3. S minus 1 is 2, s minus 2 is minus 4, and s minus 3 is minus 1. So I have initial values. And now, once again, we have no noise for the moment, just to better understand what's going on. Just to better understand what's going on, just let's calculate some few values. Konstantin, you have asked whether BT minus 1 is LT minus LT minus 1. Yes. BT minus 1 is LT minus LT minus 1. Yeah, exactly. That's growth rate, and by how much tomorrow will different. I don't say that is delta. For delta, it's customary to have a delta LT is normally, if you wonder whether, so you have something standard like just a digression, just a notation, maybe useful notation, we will use it like delta LT, yeah, should be equal to LT minus LT minus 1. Yeah, and using this notation, you are right that BT minus 1 is just delta LT. So, Konstantin, the answer for your question is yes. Okay, just a small exercise. What is the value of Y101? What is the value of Y102? And if you can calculate these two values, then you perfectly understand this dynamic system. What is the value of Y101? What is the value of Y102? That's a question to you. But that's an easy question. Just plug in. You have all the equations. You have initial values. You just plug in and you are happy. Oof. Okay, let's calculate B. Okay, let's do step by step. Who knows B1? Yeah, B is always 2. So I can even easily write B1, it's B2, and so on. It will be 2. Okay, we have calculated all B's. Okay, let's move on. Let's calculate all ST. ST, we will have a deterministic cycle. 3, 2, minus 4, minus 1. 3, 2, minus 4, minus 1. 3, 2, minus 4, minus 1. Okay? So basically, S101, we need S101 because it will cycle, yeah? Because of this simple idea, when you have S101 is if we calculate remainder by 4, yeah, every 4 observations of S are exactly the same. So S101 is exactly as S97 is exactly like S93 and so on. We can go back in the past, and if we go back into the past, we will obtain which value? S, which one? You go back by 4, by 4, by 4, maybe by 40, by 40 once more. No, we don't need to go into the future. Yes, it's equal. You are right, Елизавета, that you can go into the future, but we have past information. So yes, you are right, but yeah, we need to go into the past. So we go back by 1, by 4, by 40, by 80, by 20, because all these numbers are divisible by 4. So we can go back by 100, it's S1, by 100 once more, it's S minus 3. And S minus 3 is minus 1. This is a seasonal effect because they just make a cycle. Okay, let's move on to L. Let's move on to L 101. Or maybe L100. Let's calculate L101. What is L101? To have L101, if you look at the equation of L101, it looks a little bit like random walk, but non-random. We go up by 2 every time. L1 is 2 plus L0. L3 is 2 plus L2, and so on. We go back by 2. It's a walk, but not random. But the equation seems a little bit like the equation of random walk. So we start at we started at 100. It was L0. So it was L0, and we added B 0 plus B1 plus L dots plus the last one I think was B. The last one was B99. Yeah. And that means that I have 100 plus 2 times 100 steps, and I have 300s, I think. Yeah, any questions about L100? Why did we multiply by 100 is in the end? Why not? B0 plus B1 plus B2 plus B99. So from let's understand the logic. It's very simple. Okay, how many numbers are from B1 to B1 to B99? From 1 to 99, there are 99 numbers. But I have B0, that's number 100. And why L0 is not multiplied? Okay, let's start from L1. Yeah, Всеволод is right. We have B0, B1, and B99. Okay, let's start. If it's a little bit difficult, so let's start from L1. L1 will be L0 plus B0. It will be 100 plus 2. It will be 102. Okay, and we go step by step. L2 is L1 according to equations plus B1. It's 102 plus 2, it's 104. Maybe one more, and I think it should be clear now. I continue the same way with L3. It should be equal to L2 plus B2. That will be 106. And if you look carefully, it's like 100 plus 3 times 2. And the same happens with L100. It's the starting value, L100 plus 100 times 2 steps. It's if you live in France, it's obvious. You start, you have not the first floor, but you have some kind of rez-de-chaussée, the floor number 0. And to go from floor number 0 to floor number 99, you need to make 100 stages. Okay, so now we understand now about why, but y is 0. Okay, why we to have y101, we just add L100, that is L100. We add B100, and we add S97. And basically we have 300s. We have 300s plus 2 plus minus 1. And finally we have 301. Okay, the dynamics in deterministic case, is it clear? The dynamics in deterministic case is clear or not? Okay. So now we go to the case with random. Sorry, we have a subtle question about difficulty. In what we need to, if you look at the model carefully, these equations are standard. So every ETS AAA model will have these equations. So every ETS model, ETS AAA model will have, sorry, it's kind of without error. So it's without error, but every ETS will have these equations. And there are parameters that will be estimated by computer by maximum likelihood. These are the parameters. So computer will estimate B0, L0, S0, S-1, S-2, S-3. But there is a small trick. These starting value of B can be arbitrary. So computer can give you any number. Starting value of L0 can be also arbitrary. These are estimated by computer. So let me clearly state it. So normally, so initial values are estimated by computer. So by maximum likelihood on computer. But just an idea that initial B can be arbitrary, initial L can be arbitrary, but initial S0, S-1, S-2, S-3 should be, they have a link. Who can say me how they should be linked? They cannot be completely arbitrary. how S0, S-1, S-2, S-3 should be linked, initial values, initial seasonal effects, how they should be linked. What is the relationship I have not written between starting values of S? So this link is present. You can maybe see it, but okay, there is, yeah, exactly. Several sum of initial sum of S should be 0. Yes, there is a hidden equation. Hidden equation. Let me add here. Hidden equation S0 plus S minus 1 plus S minus 2 plus S minus 3 should be equal to 0. And why so? Why do we need such a restriction for initial values of S? Why they just cannot be 1, 2, 5, and 10? And they will go 1, 2, 5, 10. Why 1, 2, 5, 10, 1, 2, 5, 10? Why that's a bad idea to have initial values of S that do not sum up to 0? So you're right, but why? Because they eliminate each other, we will lose stationarity. We don't speak about stationarity at all, that like a sin function. The reason is simply to make a trend, to make LT interpretable. This hidden equation, so let's speak about equation. So we need equation we need this equation to interpret LT as version of YT cleared from seasonal effects. Otherwise, let me show the picture. Maybe on the picture it's very easy to see why do we need such a hidden equation. Let me show you on the picture, because on the picture it's very easy. Okay, I will just draw a picture. It's picture 1, and we'll have picture 2. Picture 2. What do we have? We have, imagine that S0 is 1, S1, S minus 1 is 2, S minus 2 is 7, S minus 3 is 10. Then what will you have? You will have LT that evolves like this. This will be LT. And you will add 1, 2, 7, and 10 to this line. If you add 1, 2, 7, 10 to this line, you will have 1, 2, 7, 10. 1, 2, 7, 10. 1, 2, 7, 10. 1, 2, 7, 10. And your process will go like this. And so on. And so this will be YT, and this will be, what do you call, YT cleared from seasonal effects. But that would be strange if your time series goes like this and your cleared version goes below your real line, always below your real line. Yeah, sometimes it may be below your line, but if you would like to interpret LT as clear it from seasonal effects, that would be strange to have LT that is always below YT. And the difference between YT and LT is just S1, S2. So these small differences are just, or maybe pink is not so good, but maybe I should prefer green. This is S1, this is S2, this is S3. These differences are S1, S3, and so on. So to avoid such non-interpretable LT, to have a good interpretation of LT as YT clear it from seasonal effects. So LT is basically just a trend. So basically to have a good interpretation, we start with initial S0, S-1, S-2, S-3 that add up to 0. Okay, that is clear. Yeah, LT should be in the middle of my process. Yeah, to have an interpretation as cleared version of YT. Otherwise, it's not a clear version. It's something strange. Okay, so let's go back to our situation. And now I think let's add noise, and with noise we will have a honest AAA model. So now let's add noise. Maybe just a small question to you before we add noise. The last question. So for the moment, I'm not writing explicitly the function, the maximum likelihood function. Let's wait a little bit. But the question we can already answer. Let's consider ETS model without noise for the moment, without noise. How many parameters do we need to estimate? So how many parameters we really need to estimate how many parameters do we really need to estimate to completely specify the behavior of the model? How many parameters? 1, 2, 3, 4, 5. How many parameters we need to specify to completely describe our model? How many initial values do we need to completely specify the behavior? Wesley, can you just count? Just take your fingers. B0, L0, S0, S-1, S-2. Do we need to specify S-3, or it can be calculated from equations? Yeah, we have an equation that make our LT interpretable. So do not forget about the missing equation. Yeah. So to completely specify, we cannot be free in specifying initial S1, S-1, S-2. So we need to specify only 3 seasonal effects in our case. because the fourth one will be calculated from the equation that says the sum of the fx is 0. So basically, we need 5 parameters to estimate. 5 parameters. So they are B0, L0, S0, S-1, and S-2. One more question. How many parameters in ETS AAA model without noise? For the moment, without noise. We will introduce noise in a moment. That was the answer for quarterly data. And how many parameters we need to estimate for monthly data? So what will change for monthly data in our setup? For monthly data, how many parameters will we need? Yeah, exactly. We will have L0, B0 as before. We will have 11, not 12 seasonal initial values. So we have 13 parameters in total. Okay. I think we're now ready to introduce ETS model with random noise. Okay, I will just copy my model. I will just copy without noise. And I will just copy, and we will plug in almost every equation random noise. Okay, now the same, we will change a little bit. This is just a copy, it will change. But to start with, we have familiar equations. We will just alter them a little bit. So we have random fluctuations now, random noise. We'll denote it by UT. And we will assume a little bit more. It will be a white noise, but we will make more assumptions. What will be the assumptions? First, we will say that UT has a normal distribution with mean 0 and variance sigma squared u. So the random term that will enter some of the next equations. They will be normal with mean 0 and variance sigma squared. And they will be independent. So they will be independent. Okay, now let's introduce noise into equations. Obviously, if something random happens, for example, you observe, so the indicator is, so imagine that our YT is some, I don't know, consumption. And so imagine that something positive happens, I don't know, maybe the wages, maybe some positive happens. So you will observe positive news just now. So if UT current random effect is positive, then you will have higher Y. Yeah. So the first thing we will add, first modification we will make, we will add current random event, current random noise in our observed Y. So it will be YT. If something good happens, for example, you have found 5,000 rubles on a street and you just decided to buy coffee. So you have immediate effect. You have found something positive UT, and you have positive effect on YT. But maybe you have found 5,000 rubles and you have, oh, that will, I can buy a coffee every Monday for almost 1 month. Oh no, every Monday, so I can buy a lot of coffee for 5,000 rubles. So this UT will influence in ETS model, some positive news will influence not only current observed value Y, but it may influence decisionalized L. It may influence seasonal effects. It may influence growth rate. So random noise in the model can influence every equation, in exception of the last one, normalization equation. So I will add UT in every equation. But the idea of ETS model is that the influence of UT is different. Maybe it will influence BT and ST not by the same amount. It will influence, but I will add some coefficients. I will add the coefficient beta here. So random noise will influence growth rate, but with some other force, with some other amplitude than immediate influence. Random noise will influence ST seasonal effect. Maybe something happened. So for example, I don't know, COVID arrives and you have immediate effect, and every and every spring, every autumn, you have a seasonal new effect. Yeah. So something new may influence current value and may influence future seasons. So I will have some gamma times UT, and this cleared value may be also influenced with some coefficient. So with alpha times UT. So basically, now we have ETS model with noise. Sorry, it's written without, but it's with noise. So now we have a complete setup of ETS with noise. Okay, any questions? So we have introduced random noise in almost every equation except the normalizing one. Okay, any questions? Okay, no questions. Let's discuss what we can. Just a quick question before a break, and after the break we will continue. We will try to understand how we can predict, make point predictions, make interval predictions in ETS model. How can we decompose time series into seasonal effects and so on. So basically now we have something random. So in this model, BT is not a constant. BT may change. That's a good news. Maybe you have something with one slope and then slope changes a little bit. So we see that in our new model, the slope is not constant. It's more or less equal to the previous slope, but it may change. The seasonal effect is roughly equal to the previous seasonal effect, but it may change. January of this year is like January of the past year, but it may change. The effect may be more expressed or less expressed this year. Okay, so we have introduced randomness in our model. So my small question before a break, how many parameters do we need to estimate? how many parameters do we need to estimate in a standard ETS model, classical. Yeah, I will just copy. I will just provide you the full text. So yeah, all links. Do, do, yeah, in quarterly. How many parameters do we need? So we need 5 parameters without noise. And now let's count how many new parameters do we have in equations. So we have 5 old parameters. 5 plus. Who can count? How many new parameters are in our system? Who can see new parameters? Who can name them? What are the new parameters? Alpha, beta, gamma, and who else? Just look at the equation. No, ut is not a parameter. It's a random variable. Yeah, sigma or sigma squared. Yeah. We will also estimate not only the force with which ut influences every equation, but the amplitude of ut is also. So we finally have 9 parameters to estimate. Okay. Now we will use this. So then after a break, we will continue. Let's have 10 minutes. And after 10 minutes, what we will do? What's the plan? We will understand how to make seasonal decomposition using estimated ETS model. We will answer the question how to make predictions. How to make predictions. I speak about both types of predictions. Interval and point predictions. And now I think, yeah, I have a question from Ilya. I need to download it first. Oh, it's a horrible Zoom. Okay, that's a question. PNG. Personal financial assets. I don't understand. What do you mean? Okay, so let's have a break and we will continue after a small break. The plan is how to make seasonal decomposition using estimated ETS model, how to make predictions using estimated ETS model. Maybe we will write likelihood function for a simple model. We need to discuss versions of ETS model, and then some general ideas, forecasting ideas like metrics, like train test split and cross-validation, but I think it's more or less easy. Okay, let's have a break for 10 minutes and continue afterwards. Any questions? Okay, so let's have a break.